Okay, guys, so for today's lesson, we are focusing on what's called percent composition. And so this is going to directly tie into what we're also going to talk about on, we're not going to talk about it, but you guys are going to see it on Monday because it's an asynchronous day. So we won't have like a live Zoom class on Monday. So if you guys have not already been told by your other teachers, Monday, which is an A day, is another asynchronous day that was already pre-planned. So I know we've been having a lot of those lately just because of all the weather and everything going on. But they had already had this one pre-planned, and so they're not changing it or anything. So just know that for today, after we do this lesson, when you guys log in on Monday to Canvas, there will be a lesson posted for you guys that you need to make sure that you go through and complete. And then there'll be kind of an assignment that goes with it. Okay. If you've run into any trouble or have any questions about the stuff on Monday, since we're not having a Zoom, you can always reach out on a Remind or here in the Canvas inbox if you have any questions or if you're kind of still confused about what exactly you're supposed to do. Okay. So for today, we're doing percent composition. So on your notes on here, there's a few videos. You don't have to watch all of them. You can kind of pick, I guess. The first two are by the same person. The first two are pretty short. It just goes through one example in each video. So if you watch like the first one and the second one, and you're like, I think I got it after that, then you could go ahead and move on down to the little practice problems here at the bottom so you can kind of check yourself. If you're still a little confused, the third video here is a little bit longer, but it goes into a little bit more detail. So if the first two videos that are a little bit shorter aren't enough explanation for you, then I would advise to watch this third video that's available on here as well. And because what we're going to do on our live call today in just a minute is we're going to go through one or two examples together that are similar to what you're going to see in the video. Okay. So that being said, after you have kind of watched whichever of these videos you choose to watch, and there's there's four problems down here that you can kind of check yourself with. And so you'll be kind of reading along, typing in, and it's kind of walking you through how to do the calculation. And so what we're going to do on the Zoom call today is we are going to work through a couple of these and talk about what is percent composition. And then your actual assignment, after you've kind of done notes and you've kind of practiced at the bottom of the note page, um, your assignment is on the next page, and it is in a Google Doc. And what it looks like is you'll click here, it'll let you make a copy, and then you'll come back here to submit it when you're done. Just make sure that you do this step number 4. You got to change the permissions to viewable by anyone from AISD before you share it. Otherwise, I won't be able to open it to grade it. Okay. I know I sometimes forget to do that too. I forgot to do it on this. Somebody had to remind me this morning because they couldn't open up the assignment. So what it looks like is it looks like this. There's 8 problems on it, and it's got this structure of this table, and it's kind of set up to help you do the problems like we're going to do together in class today. And so it gives you a chemical formula at the top. And so there's a column for you to type out. You're going to list what are the individual elements in the compound. You'll list out what is the subscript. So remember, if there's no subscript, it's 1. And then here, this is just, you'll leave this blank. This is just so you know that you're actually going to be multiplying. So the X here, that's for multiplication, because you're actually multiplying the subscript by the atomic mass, because you're going to have to calculate the molar mass. Okay. And so you'll multiply, and then the total atomic mass for the element will be in this column. And then the last column is for you to do the percent composition. And so that's what we're going to talk about how to calculate today for the lesson. To do the percent composition, you'll need the total atomic mass of the element, and you'll need the total mass of the compound. So that's why there's a box down here for total mass, because you'll add up all the total atomic masses for this next to last column. When you add those up, that gives you the total mass for the entire compound. And that's the pieces of information that you'll need in order to calculate percent composition like we're going to look at today. And so you have 8 of them that you'll kind of fill in. Some of them only have, like this first one has 3 elements, so you'll only fill in 3 rows. You won't use the last row, but all of the tables are set up the same because some of them do have 4 elements. A couple of them only have 2 elements, so you may not use every row. It just depends on the number of elements. And so that's what you'll do for your assignment today. once you're done kind of with notes and going over everything. Okay. So what I'm going to do now is I'm going to switch over to the iPad so that we can work out some together. Okay, so our topic kind of today, as I said, it's called um, percent, let's see, percent composition. And so basically, we're talking about composition is kind of like the makeup, like what something is made up of. And percent, it means we're going to calculate it in a percentage form. And so we always do this using the masses of our elements. Okay. And so what we're going to do, actually, I need to scroll down to a different page. There we go. And so to calculate percent composition, we always use masses. So you'll be looking up atomic masses or molar masses to use from the periodic table. And it's an equation where you always do, you do the total mass of your element. That goes up in the numerator. So once you figure out the total mass of your element, that goes in the numerator. And the bottom is the total mass of the entire compound. So that's why what you saw on that worksheet that I was kind of showing you, it has it kind of set up in that table form to help you calculate those things to use to do this percent calculation. So what you'll have to do is you'll have to calculate molar mass, okay? And then once you calculate that for the individual elements and then the whole molar mass for the compound, those are the numbers you're going to use in here. You'll divide them, okay? So you'll do that total atomic mass or the total molar mass of the element divided by the total mass of the entire compound. And then the last thing is you got to remember that you will then multiply it by 100. That's what makes it a percentage. So you're going to divide them and then multiply by 100, okay? And so this is one of two ways that we usually talk about what compounds are made of. So it's actually the second one on here, and I'm going to shorten it because I don't want to write all that out. So I'm just going to put the percent composition. I'm going to use the percent sign. Composition. So percent composition is one way that we can describe a compound, because if we know what percentages a compound is made up of, we can identify what it is. And so this is something that they use in things like forensic science. If they're trying to identify chemicals that were maybe found at a crime scene, or if somebody had a chemical inside, their body, and they're doing like a tox screen where they're trying to figure out what killed them and what was in their stomach, they can take samples of the substances, and they have a machine that will tell them the percent composition, and then they can use that to identify what the substance is, which could lead to a clue that would help them to figure out maybe what happened to the person, or if they were killed, who killed them. The other way that we use to represent is what we're actually going to talk about on Monday, and that is called the molecular formula. So on Monday's lesson, you guys are going to learn about empirical formulas and molecular formulas. And so you'll learn kind of what each of them is and how they're different, and you'll learn how to calculate them. And so that's another way, because you can actually, same kind of concept, you can use percent compositions to calculate a molecular formula. And that's what you're going to see on Monday, is you're going to be given problems where they're going to say, hey, we found, a sample of a compound and it has this percentage, hydrogen, this percentage oxygen, this percentage carbon, or whatever elements. And they'll say, well, what's the empirical formula of it? Or what's the molecular formula of it? And you're going to learn a process for how you will use those percent compositions and to calculate in order to figure out the subscripts to write the empirical formula or the molecular formula. Okay. So we're going to look at an example. So this one says calculate the mass percent of carbon, hydrogen, and oxygen in acetic acid. Now, sometimes these problems might be worded a little differently. Instead of saying calculate the mass percent, sometimes they might just say calculate the percent composition. They'll just use that term. So anytime they say percent composition, percent by mass, mass percent, anything like that, this is the method you're going to use. Okay. So in this compound, and they've given us acetic acid, which is this chemical formula right here. Okay, it's important we have the chemical formula because we need the subscripts to do the calculation. And then they've asked us to calculate all the elements. Now, sometimes the question might only ask you for one. You know, they might just say, well, what's the percentage of carbon in this compound? Or what's the percentage of oxygen? If they only ask you for one element, you only have to do one calculation. If they ask you for all of them, or they just say, what's the percent composition of this compound? Then you have to do all of the elements that are in it. And so it's going to require more than one calculation. Okay. So how this is going to work is I need to first list out my elements. So I have carbon, I have hydrogen, and I have oxygen. And then I want to look at the chemical formula that they gave me because I need the subscripts because that's going to be needed for my calculation. So for carbon, there's a 2 subscript. So there's 2 atoms of carbon. For hydrogen, there's 4. And for oxygen, there's 2. So again, I just got that straight right from here, the chemical formula that they gave me. And remember, if there is no subscript, it's an imaginary 1. So if there's no subscripts, you'll write a 1 there. Now I'm going to multiply by the atomic mass or the molar mass of each element from the periodic table. So does anybody remember what any of these elements are from doing practice with your conversions? Or do we need to go look them up? We'll go look them up. All right. So I'm going to come over here to our reference chart with our periodic table. So we need carbon, hydrogen, and oxygen. For all these problems, we want to keep all of our molar masses and percentages. We're going to keep 2 decimal places. So when you use your reference chart here, everything's already rounded to 2 decimal places. So that makes it a lot easier. So here is carbon over here. Carbon is 12.01 for the atomic mass or the molar mass. Hydrogen is here, 1.01. And then oxygen is 16.00. It's over here. So those are the 3 atomic masses or molar masses that we need from the periodic table. So let's come over here and we're going to fill them in. So carbon is, oops, let me rewrite that. Carbon was 12.01. Hydrogen is, it was 1.01. And oxygen is 16.00. Okay. So what we will do then is multiply. So carbon 2 times 12.01, that is 24.02. And this is grams because we're doing molar mass. Hydrogen 4 times 1.01 is 4.04 grams. And then my oxygen 2 times 16, that is going to be 32. And I'll just fill in my zeros here so that everything lines up. And then to get the total molar mass for the compound, I'm going to add these together. Okay. And so if I add these together, let's see, that's a 6, that's a 0, 4, 8, 9, 10, that's a 0, and then carry the 1. So 60.06 grams per mole. Okay, that's our molar mass. So these numbers right here, these are all the numbers that we now need to calculate percentage composition, because I just showed you up here that the equation to calculate percent composition is total mass of element divided by total mass of compound times 100. And so since this question asked us to do all 3 elements, carbon, hydrogen, and oxygen, we're going to have to do 3 percentage calculations. And these are the numbers we need, okay? The ones that I just kind of boxed in red. So I'm going to come down here. So now it says calculate the mass percent of each element by dividing the mass of each element in a mole of the compound by the total molar mass. So we're going to set it up and we'll do one of them at a time. So let me switch to a different color. So I'm gonna kind of write over here because I know that my writing is going to be a little bit bigger than that space probably allows. So for the percentage of carbon, I would do the total mass of carbon. So if I go up here, what was the total mass of carbon that I had in this compound? So you can answer in the chat, or if you want to unmute. So where is carbon up here? Carbon is the C. So here's the line for carbon. So what was the total mass of carbon in the compound? Yeah, there you go, Mariah. Thank you. So 12.01, that's for one atom of carbon, but remember for the calculation, we need the total. So since we doubled it, we multiplied by 2, we have to use the 24.02 for carbon. So it will be 24.02 grams. And then I'm going to divide by, and if we go back up here to look at the equation, we're dividing by the total mass of the compound. So that's the whole molar mass of the entire compound. So for that, what number would we use for the total molar mass for the entire compound? Based on what we have kind of up here to work with. Let me scoot it back up. Yes, thank you. So it would be this, it's the total here at the bottom. Okay, so it's 60.06, that's the molar mass of the entire compound. And then I multiply by 100. And that's going to give me the answer for the percentage of carbon. Okay, so I would do 24.02 divided by 60.06 and then multiply by 100. And that's it. I'm done with carbon. And then now I have to do the same process for the hydrogen and the oxygen. Now, for your percentages, in the practice numbers that are online on the notes, you're rounding to 2 decimal places for the percentages. So for this one, I get 39.99%. Okay, for the carbon. Now for the hydrogen, process is the same, but our numbers are going to be different. So for the percentage of hydrogen, I'm going to use the total over here for the hydrogen, which would be the 4.04 grams because we had to multiply it by 4. And then I would divide this number on the bottom stays the same because it's the total mass of the compound never changes. And then times 100, and then same thing. Okay, so 4.04 divided by 60.06 times 100. And then again, I want to keep 2 decimal places. So this one's going to be 6.73%. And then I have to do it one more time for the oxygen. I'm going to scroll down here, kind of running out of space, but that's okay. All right, so percentage of oxygen is total for the oxygen was 32. So when I go to set this one up, I have 32.00 grams divided by, and then again, my denominator, the number in the bottom, stays the same because the mass of the compound does not change. And then multiply by 100. So 32 divided by 60.06 times 100. And then rounding it to 2 decimal places, we get 53.28%. So this compound, over half of it is oxygen. Okay, hydrogen's actually very little of it. Even though hydrogen had the most atoms, it had the highest subscript. Hydrogen atoms are very small in mass. So total out of this whole compound, it's not even 7%. Okay, so just because an element has a subscript that's a bigger number doesn't mean that's going to have the higher percentage, because it's not just the subscript, it's the subscript and the atomic mass that affect it. Okay. A trick to check yourself on problems like this one, where they ask you to do all of the elements in the compound. One way to check your work is add up your percentages, because percentages are out of 100. So if you add up 39.99 and 6.73 and 53.28, you should get 100% or really close to it. Because remember, we did have to round it. So you might get like 99.99, or maybe 100.01. But it should be right close to 100 because it's a percentage. If you add them together and you get something that's like 120 or like 78, that's like way off, then you did something wrong. And typically, what most people do wrong is this top number for the element. They forget to use the one that's the total that's after you multiplied, and they use the one that's just the single atom. So they use like the 12.01 for the carbon, and the 1.01 for the hydrogen, and the 16 for the oxygen. So make sure that you are not confusing yourself in doing that. Okay. So that's basically it. That's the process. So let me switch back over to, we can look at Canvas together again. So as I said, when you are working on your stuff later, the first two videos on here, they're really short. They're basically what I just did. Each one has one example worked out. So if you want to see another one worked out beyond what we did, then definitely watch that. And I think the second one even has, it has a compound that has like a polyatomic ion where it's in parentheses. So if you want to, refresher on, how do you distribute the subscript in parentheses and how to multiply that correctly, definitely watch that one. And then beyond those two, if you're like, I still need some more detail, some more help, I would watch this last one because it goes into a lot more detail than the first two. And then once you're done with those, you have these 4 problems down here. You can practice checking yourself. And it's going to lead you through kind of exactly what I did. So it tells you to kind of, here's the percent composition of this compound, nitrogen dioxide. So it tells you to look up the atomic or the molar masses of the elements. You're going to round them to 2 decimal places, which they should already be rounded like that if you're using the periodic table that we have for on a reference chart. So you'll type them in here. And then it asks you how many of the atoms are in the chemical formula. So you would look at the subscripts. And so it says, so you'll need to multiply this element by, whatever number. And now it's asking you to calculate it. So you'll calculate it just like we did on the example, round it to 2 decimal places. You'll type your answer in here so you can check that you did the molar mass correctly. And then once you have the molar masses, then you'll calculate the percentage of the 2 elements in the compound. You'll round them to 2 decimal places like we just did on the example. And you'll type the answer for both of them in here, and then you can check yourself. And so there's that one, and then there's 3 more problems, okay, that are similar. So you can kind of check yourself a few times, make sure you're getting the process correct and your answers are right. And then once you're comfortable and you've practiced all that, then you'll go on to your practice worksheet. And like I said, you'll open it, you'll make a copy of it, and then it gives you the formula and it has a table so you can list out your elements, write your subscript, write the atomic mass, and then you'll multiply. The total mass goes here. And then you can add all of those up to get the total molar mass down here. And then you'll use the total atomic mass of this element, divide it by the total mass of the compound, multiply it by 100, and you'll type your percentage here in the very last column. Okay. That's pretty much it for today. So